Picture this: a signal cuts through the vast silence of space. A burst of energy so precise, so deliberate, it doesn't match anything we've ever seen in nature. It's not the chaotic scream of a dying star or the steady heartbeat of a pulsar. No, this pulse feels engineered, as if someone or something crafted it with purpose. And then, just as suddenly as it appeared, it vanishes, leaving behind one haunting question. Were we just heard by a civilization that no longer exists? For decades, astronomers have been catching these fleeting whispers from the cosmos radio, bursts that defy explanation, patterns that seem too perfect to be random, echoes that carry the weight of something profound. Some repeat like clockwork, others flare once and disappear forever, but all of them challenge everything we think we know about the universe. These aren't just cosmic anomalies, they're potential messages, time capsules sent across millennia by civilizations that may have risen, flourished, and vanished long before Earth even formed. Imagine the tragedy or the triumph of a signal that outlives its creators, a final "we were here" etched into the fabric of space itself. Today, we're embarking on a journey through the unknown, exploring 30 of the most baffling, electrifying pulses ever detected, signals that could rewrite our understanding of life, intelligence, and our place in the cosmos. Some might be natural phenomena we just don't comprehend yet, but others feel like they're speaking to us. What if we're not just searching for extraterrestrial life, but for its ghosts? By the end of this, you'll never look at the night sky the same way again. So lean in, turn up the volume, and let's listen, really listen, to what the universe might be trying to tell us. Imagine a radio station broadcasting from the edge of the universe, its signal cutting through the cosmic static with eerie precision. That's the enigma of anomalous pulses, bursts of energy so unusual they don't fit any known natural template. Unlike the predictable rhythms of pulsars or the chaotic blasts from supernova, these pulses carry patterns that feel almost intentional. Some arrive like clockwork, repeating at intervals so exact they defy randomness. Others flicker with spectral fingerprints unlike anything in our astrophysical catalogs. Take radio waves, for instance, the most common form these pulses take. Natural cosmic sources like collapsing stars or swirling black holes produce radio emissions, but they're messy, sprawling across frequencies like static on an old television. Anomalous pulses, though, they're laser-focused, narrow-band, concentrated, as if someone tuned the dial to a specific channel. Scientists call this bandwidth compression, and it's one of the hallmarks that set these signals apart. It's the difference between hearing a thunderclap and a whispered sentence. One is raw power, the other carries structure. Then there's the timing. Some of these pulses repeat with mathematical regularity, like a metronome ticking across light years. The famous F.R.B. 121102, for example, fires off bursts every 157 days, a cycle so precise it feels engineered. Nature thrives on chaos. Storms don't follow schedules, and stars don't explode on cue. So when we detect a cosmic timer, it begs the question, is this the universe's randomness or the signature of something more deliberate? Spectral properties add another layer of intrigue. Normal cosmic radio waves smear across a range of frequencies, but anomalous pulses often spike sharply at specific points, like a needle scratching a vinyl record in just one groove. Some even drift in frequency over time, as if the sender were adjusting their transmitter. It's these subtle quirks that fuel debates in astronomy circles. Could these be artifacts of alien technology, leaked signals from propulsion systems, or perhaps the last gasps of a dying civilization's communication network? Or are we simply witnessing exotic physics, phenomena so rare we've yet to categorize them? Theories abound. One camp argues for natural but extreme explanations. Magnetars, neutron stars with magnetic fields so intense they twist spacetime itself, could be culprits. Others point to cosmic strings, hypothetical defects in the fabric of the universe vibrating like plucked guitar strings. But then there's the unsettling possibility that some pulses are exactly what they seem, deliberate broadcasts. Not necessarily messages to us, of course. They could be ancient navigation beacons, emergency distress calls, or even the cosmic equivalent of a dropped phone call, fragments of a transmission cut short by time or tragedy. What makes these pulses so tantalizing is their ambiguity. They're outliers in every sense, dancing just beyond the edge of our understanding. Every new detection is a riddle wrapped in static, a puzzle that could rewrite textbooks or reveal that we've been eavesdropping on ghosts. The search isn't just about finding answers, it's about learning how to ask the right questions, because if even one of these pulses is artificial, the implications are staggering. We wouldn't just be discovering life beyond Earth, we'd be hearing from a civilization that may have vanished before humans first stood upright, and that changes everything. The universe is unimaginably vast, with billions of galaxies, each containing billions of stars statistically. Life should be everywhere, yet when we listen, all we hear is silence. This is the heart of the Fermi Paradox, the glaring contradiction between the high probability of extraterrestrial civilizations and the complete lack of evidence for them. But what if we've been looking or listening the wrong way? Those strange, unexplained pulses from deep space might not be greetings from living civilizations. They could be cosmic obituaries, the final transmissions of societies that flared brightly and then vanished long ago. Consider this sobering idea. The average lifespan of a technological civilization might be tragically short. War, environmental collapse, resource depletion, any of these could snuff out a culture shortly after it develops the ability to broadcast its existence. If that's true, the galaxy could be littered with the echoes of dead civilizations, their last messages still traveling through the void like ripples from a stone thrown into a pond. These anomalous pulses fit eerily well with theoretical technosignatures, patterns scientists predict might appear in artificial signals. Narrowband frequencies, precise repetition, spectral oddities, they're all hallmarks of engineered communication, not natural astrophysics. Take the fast radio bursts we've detected, those millisecond blips of energy from billions of light years away. Some arrive with mathematical regularity, like clockwork ticking across cosmic time. Nature rarely creates such perfect rhythms without a reason, but if these are artificial, their sheer power suggests they weren't meant for us. A civilization on the brink of collapse might dedicate its remaining energy to one monumental broadcast, a final "we existed," hurled into the darkness. By the time those signals reach us, their senders could have been dust for eons. This changes how we view the Fermi Paradox. The silence isn't necessarily silence, it might just be delay. The universe is so vast that signals take millennia to cross even a fraction of it. We could be surrounded by the last cries of extinct cultures, their messages only now arriving at our doorstep. The pulses we've catalogued might be fragments of a galactic graveyard, whispers from civilizations that burned out before Earth cooled. The implications are haunting. If most civilizations self-destruct shortly after reaching technological maturity, the galaxy could be a gallery of tombstones, those anomalous pulses. They might not answer the Fermi Paradox, they might embody its darkest resolution. We aren't alone, we're just late to the funeral. It was just another quiet night at Ohio State University's Big Ear radio telescope on August 15, 1977, until the universe screamed. For 72 seconds, a signal blared from the constellation Sagittarius, so intense that astronomer Jerry Amon circled it on the printout in red ink and scribbled, "Wow." Beside it, that single word would immortalize the most tantalizing blip in the history of the search for extraterrestrial intelligence. What made it extraordinary wasn't just its strength, but its precision. The WOW signal hit exactly 1,420 megahertz, a frequency sacred to radio astronomy because it's where hydrogen, the universe's most common element, naturally resonates. Narrowband, unmodulated, and vanishing without a trace, it matched every criterion scientists had theorized an alien broadcast might follow. Decades later, the mystery only deepens. Recent analysis pinpoints its origin near a sun-like star 200 light-years away, a prime candidate for hosting habitable worlds. Yet despite countless efforts to recapture it, the signal never repeated. Was it a one-time beacon, a cosmic flare gun shot blindly into the dark, or something more haunting, a message from a civilization that flickered out centuries before we even heard their hello? The Big Ear telescope itself is gone now, dismantled in the 1990s, leaving us with just that single, enigmatic page of data. Critics argue it could have been a passing comet reflecting Earth's own radio noise, except comets don't emit narrowband signals. Others suggest military satellite interference, but declassified records show no matching transmissions. The most unsettling possibility lingers. What if it was intentional but not meant for us? Imagine a civilization broadcasting in all directions, their signal sweeping the galaxy like a lighthouse beam. By the time it grazed Earth, the senders might have already vanished, their hello reduced to a fossilized whisper. The WOW signal endures not just as a scientific puzzle, but as a poetic metaphor for our cosmic loneliness. It's the universe teasing us with a single page of a story we'll never get to finish. In the quiet hum of archived data from the Parkes Radio Telescope in Australia, a single blip rewrote the rules of cosmic mystery. It lasted just 5 milliseconds shorter than the blink of an eye, but packed the energy of 500 suns. Duncan Lorimer and his student David Narkevic stumbled upon it in 2007, buried in observations meant to study pulsars. What set this burst apart wasn't just its raw power, but its origin. It had traveled an unthinkable 3 billion light-years, making it the first intergalactic radio burst ever detected. The Lorimer burst, as it became known, shattered assumptions. Its dispersion, the way its higher frequencies arrived slightly before the lower ones revealed it had sliced through ionized gas, a fingerprint of its epic journey. Yet no known cosmic catastrophe could explain it. Supernova too weak, colliding neutron stars too messy. This was a clean, focused spike, like a laser beam cutting through the dark. The most unnerving detail, it never repeated. Unlike pulsars or even some later fast radio bursts, this was a one-off event, a cosmic shout with no echo. That singularity fueled wild theories. Could it have been the death cry of an exotic object, a magnetar collapsing into a black hole, or a quark star tearing itself apart? Or perhaps something more deliberate, a beacon, intentionally brief, meant to stand out against the noise of the universe. The burst's brevity is what lingers in the imagination. 5 milliseconds is barely enough time to say hello, let alone convey meaning. But if it was artificial, it might not have been meant for us. Imagine a civilization broadcasting a single, powerful pulse in all directions. A time capsule hurled into the void, indifferent to who or what might eventually intercept it. By the time it reached Earth, its creators could have been extinct for billions of years. The Lorimer burst's true legacy isn't just the mystery it embodies, but the door it kicked open. Before 2007, no one was systematically searching for millisecond radio bursts from other galaxies. Now, telescopes worldwide scan the skies for these fleeting anomalies. each detection adding pieces to a puzzle we're only beginning to assemble. Some scientists argue these bursts could be far more common than we realize, cosmic fireworks popping off every second across the universe, most going unnoticed. But the Lorimer burst remains the Rosetta Stone of the phenomenon, the first clue that the universe might be far noisier and far stranger than we ever imagined. What's chilling is the scale. 3 billion light-years means this pulse began its journey when Earth was a lifeless rock before multicellular organisms existed. The light from that burst outlasted stars, galaxies, possibly even the civilization that might have created it. And in that 5-millisecond flicker, it handed us a question we're still trying to answer. Are we listening to the universe's natural chaos or the faint, fading signatures of those who came before us? Most cosmic signals flare once and vanish, leaving scientists scrambling to decode their meaning from a single fleeting moment. But F.R.B. 121102 breaks all the rules. It keeps talking. Discovered in 2015, this fast radio burst didn't just shout into the void. It established a pattern, repeating every 157 days like a celestial metronome. Nestled inside a dwarf galaxy 3 billion light-years away, its home is a chaotic stellar nursery where young stars burn fiercely and supernova light up the darkness. This turbulent environment makes its precise rhythmic bursts even more perplexing. Nature thrives on randomness, yet here's a signal punching time cards across cosmic distances. What sets F.R.B. 121102 apart isn't just its discipline, it's the layers of mystery wrapped around it. While most fast radio bursts are thought to originate from cataclysmic one-time events, like neutron stars colliding, this repeater suggests something far more stable. Some theorists propose it could be a malfunctioning piece of alien technology, perhaps a massive power generator leaking energy in rhythmic bursts as it spins, or a broken beacon still transmitting on autopilot long after its builders disappeared. The idea isn't as far-fetched as it sounds. Imagine a civilization constructing a network of interstellar navigation beacons only for one to outlive its creators, dutifully blinking into the abyss with no one left to hear it. Then there's the location. Dwarf galaxies are cosmic toddlers, small and bursting with star formation, but lacking the heavy elements needed to build advanced technology, at least by our understanding. If this signal is artificial, it challenges our assumptions about where intelligent life might arise. Could a civilization have emerged in this turbulent cradle, only to flicker out before maturing? Or is the repeater something else entirely, a natural phenomenon we've yet to imagine? One compelling theory involves a highly magnetized neutron star, or magnetar, entangled with an orbiting companion. As the magnetar's powerful magnetic field interacts with debris or stellar winds, it might generate periodic bursts. Yet even this explanation struggles to account for the signal's eerie consistency. The most haunting possibility is intentionality. If F.R.B. 121102 is a message, it's not necessarily meant for us. 3 billion light-years means this signal began its journey when Earth was a lifeless rock. It could be a distress call from a dying civilization, a warning beacon marking a hazardous region of space, or even a test signal for some long-forgotten technology. The repetition suggests endurance, a signal designed to persist, to outlast empires and stars alike. What makes this repeater so electrifying is the questions it forces us to confront. Are we witnessing the death throes of a natural cosmic oddity, or the last gasp of something that once thought, built, and dreamed? Every 157 days, as the signal resurfaces, it's as if the universe is whispering a riddle we're only beginning to understand. And with each cycle, the line between astrophysics and archaeology blurs just a little more. In the quiet hum of data from the Breakthrough Listen project, a single blip from our closest stellar neighbor sent shockwaves through the scientific community. BLC-1, detected in 2020 from Proxima Centauri, just 4.2 light-years away, wasn't just another cosmic blip. It was a narrowband signal, a whisper of radio waves concentrated at 982 MHz, eerily close to the frequency range where human-made satellites typically fall silent. For a fleeting moment, it seemed we might have intercepted a hello from next door. The excitement was electric. Proxima Centauri hosts at least one potentially habitable planet, Proxima b, a rocky world nestled in the star's Goldilocks zone. If BLC-1 was artificial, it wouldn't just confirm extraterrestrial intelligence, it would place it practically in our backyard. The signal's narrowband nature was the first red flag that this wasn't ordinary cosmic noise. Natural astrophysical phenomena tend to broadcast across a wide range of frequencies, like a radio tuned to static. BLC-1, by contrast, was a laser-like spike, the kind produced by human technology every day. But here's the catch: it originated from a point in space where no human spacecraft or satellites should have been. Skepticism quickly tempered the initial euphoria. Further analysis suggested the signal might be interference, a rogue transmission from Earth bouncing off space debris or a passing satellite. Yet even as the likely explanation tilted toward the mundane, BLC-1 left an indelible mark on the search for extraterrestrial intelligence. Its very ambiguity is what makes it profound. The signal's fleeting nature, appearing just once over 30 hours of observation, mirrors how we might expect to hear from an extinct civilization. Not as a continuous broadcast, but as a momentary flicker, a brief burst of energy before the cosmic silence reclaims it. This is the haunting lesson of BLC-1. The universe is awash in noise, and buried within it might be the faintest whispers of civilizations that flared and faded. Distinguishing between a distant culture's last gasp and terrestrial interference is like sifting for gold dust in a sandstorm. The Breakthrough Listen team's own caution underscores the razor-thin line between discovery and false hope. They labeled it a candidate signal, not proof, a reminder that extraordinary claims require extraordinary evidence. What if BLC-1 had been genuine? A signal from Proxima Centauri would imply a civilization capable of radio technology, but not necessarily one that still exists. Even at such a short cosmic distance, 4.2 years is a long time for a society. The light we're seeing now would have left their world in 2016. In the span between transmission and reception, a civilization could have risen, fallen, or transformed beyond recognition. That's the eerie reality of interstellar communication. We might only ever hear echoes, never conversations. The controversy surrounding BLC-1 isn't just about one signal, it's about how we navigate the vast gray area between skepticism and wonder. It's a dress rehearsal for the day we might detect something truly unambiguous. Until then, these tantalizing near misses keep us sharp, reminding us that the universe is under no obligation to make its secrets easy to decipher. Every false alarm hones our tools, refines our methods, and steels us for the moment when the signal isn't a maybe, but a definitive, universe-altering yes. Canada's Chime telescope sits in the rolling hills of British Columbia, a sprawling array of half-pipe antennas designed to catch whispers from the cosmos. Since its launch in 2017, it's become the world's most prolific hunter of fast radio bursts, cataloging hundreds of these fleeting cosmic anomalies. But among the chaos of random blips, one signal stands apart: Chime 180916. This isn't just another burst, it's a cosmic timepiece, pulsing with a precision that feels almost mechanical. Every 16.35 days, like clockwork, the signal flares to life, then fades back into silence. In a universe ruled by entropy, such exact repetition isn't just rare, it's borderline unnatural. What makes Chime 180916 so baffling is the sheer discipline of its rhythm. Natural cosmic phenomena rarely adhere to strict schedules. Stars flicker unpredictably, black holes belch energy at random intervals. Even pulsars, the universe's most reliable timekeepers, eventually slow down or wobble. But this signal, it's as if someone set a celestial alarm to ring every 392.4 hours. The odds of such regularity arising by chance are astronomically low, leaving scientists with two equally mind-bending possibilities. Either we're witnessing an exotic natural process we've never encountered before, or we've stumbled upon something that was built. Theorists scramble for explanations. One camp argues it could be the death throes of a highly magnetized neutron star, its rotation or precession creating a periodic window for bursts to escape. Imagine a lighthouse with a slowly spinning shield. Light only flashes through when the gaps align. But even this elegant model struggles to account for the signal's flawless timing over years of observation. Others propose a binary system, where a neutron star's orbit around a companion star periodically positions it to fire bursts toward Earth. Yet no known binary pair matches this precise 16-day cycle. Then there's the unsettling alternative, artificiality. If this signal is engineered, its purpose is anyone's guess. Could it be a navigation beacon left behind by a civilization that once charted the stars? The 16-day interval might correspond to some universal constant or cultural significance lost on us. Or perhaps it's a fail-safe mechanism, a dying society's last act, programming a transmitter to outlive them, ticking away the eons until someone notices. The signal's location deepens the mystery. Originating from a star-forming region in a spiral galaxy 500 million light-years away, it emerges from a stellar nursery where young, chaotic stars dominate. Not the most hospitable place for life as we know it, unless the signal isn't from the region itself, but something passing through it. The implications ripple outward. If Chime 180916 is natural, it reveals a gap in our astrophysical knowledge, a new class of object or phenomenon hiding in plain sight. But if it's artificial, that changes everything. 500 million light-years means this signal began its journey long before multicellular life existed on Earth. By the time it reached us, its creators, if they ever existed, could have vanished without a trace. Their beacon would then be less a message and more a monument, a cosmic tombstone marking a civilization that once reached for the stars. What keeps astronomers awake at night isn't just the signal's mystery, but its persistence. While other repeating fast radio bursts occasionally shift their patterns or go silent, Chime 180916 has maintained its rhythm like a metronome for years. That consistency suggests stability, something enduring in a universe where everything eventually crumbles. Whether natural or not, this pulse challenges our assumptions about the cosmos. It's a reminder that the universe may still hold surprises too strange for our textbooks or our imaginations. Every 16.35 days, as the signal resurfaces, it's as if the cosmos is tapping us on the shoulder, asking, "Have you figured it out yet?" And so far, the answer remains a humbling silence. Andromeda is the galaxy we know best, our closest cosmic neighbor, a swirling twin to the Milky Way just 2.5 million light-years away. That's why the pulse detected in 2015 sent such shockwaves through the astronomy community. Unlike distant fast radio bursts from billions of light years away, this signal came from right next door, and it carried quirks that made zero sense. Most cosmic radio emissions follow predictable frequency patterns like a steady musical note, but this one drifted, sliding up and down the spectrum as if someone were tuning a dial mid-transmission. Natural objects don't do that. Stars don't modulate their signals. Black holes don't tweak their frequencies. Yet here was something in Andromeda breaking all the rules. The signal's proximity is what makes it so electrifying and so unsettling. 2.5 million light-years may sound vast, but on the cosmic scale, it's practically shouting distance. If this pulse were artificial, it wouldn't just imply intelligence elsewhere in the universe, it would mean they're right in our backyard. Andromeda has long been considered an unlikely host for technological civilizations. Its stars are older and more metal-poor than ours, with fewer of the heavy elements needed to build complex technology. Yet there it was, a signal that looked less like astrophysics and more like engineering. Scientists scrambled for natural explanations. Could it be an unknown type of pulsar, one with bizarre magnetic fields that twist its emissions? Maybe, but no known pulsar model accounts for that unnatural frequency drift. Another theory suggested interference from a passing satellite, except the signal's origin point didn't match any human-made object. The most haunting possibility is that we were hearing something left behind. Imagine a civilization that rose in Andromeda millions of years ago, launching probes or beacons before collapsing. Their technology, now derelict, might still be transmitting corrupted signals like a radio left playing in an empty house. The signal's ephemeral nature deepens the mystery. It appeared just once, never repeating despite years of follow-up observations. That fits a grim pattern. Many of these anomalous pulses feel like final acts. A dying transmitter, its power faltering, might emit one last distorted burst before going dark forever. The frequency drift could then be a telltale sign of systems failing, like a flashlight flickering as its batteries die. What chills researchers isn't just the signal's strangeness, but its source. Andromeda is the one galaxy we're certain will collide with the Milky Way in about 4 billion years. If intelligent life once thrived there, its remnants might someday literally cross paths with us. That raises a provocative thought. Could this pulse be less a message and more a monument? Not a hello, but a we were here, etched into the cosmos by a culture that knew it wouldn't last. The Andromeda signal lingers as both a tantalizing clue and a cautionary tale. Its very existence suggests the universe might be littered with the debris of fallen civilizations' artifacts we're only beginning to recognize. And if we keep listening, who knows? The next whisper from next door might not be a solitary pulse, but a chorus. Deep in the static of old telescope recordings, buried beneath decades of cosmic noise, lies a signal that defies time itself. The park's Dinosaur, as astronomers call it, isn't just mysterious, it's ancient. Detected by Australia's iconic Parkes radio telescope, this pulse carries a dispersion signature so stretched, so weathered by its journey, that scientists estimate it began traveling when dinosaurs still ruled Earth. Imagine that for a moment, a burst of energy hurled into space 65 million years ago, before the Chicxulub asteroid reshaped life on our planet, only to finally reach us now, long after its senders, if there were any, vanished without a trace. What makes the dinosaur pulse so extraordinary isn't just its age, but its endurance. Most cosmic signals fade or scatter over interstellar distances, their structure eroded by dust and magnetic fields. Yet this one arrived with a coherence that hints at something deliberate. Natural pulses from neutron stars or black holes tend to smear across frequencies like ink in water. The dinosaur, though, retained a sharpness, a clarity that feels almost engineered. Some researchers argue it could be the remnant of a colossal astrophysical event, like a hypernova or a magnetar's final convulsion. But others whisper a more haunting possibility. What if it's not a death rattle but a fossil? A time capsule from a civilization that rose, thrived, and fell during Earth's Cretaceous period, their last transmission only now washing over our antennas. The implications are staggering. 65 million years is an unfathomable span, long enough for continents to shift, stars to be born and die, and entire evolutionary epochs to unfold. If the dinosaur pulse is artificial, its creators wouldn't just be extinct. Their very star system might have dissolved into the galactic background by now. Their signal, though, persists a ghostly footprint in the cosmic sand. This raises a chilling question. Could the universe be full of such echoes, overlapping messages from civilizations that never coexisted, their calls crossing in the dark like ships passing in an endless night? The Parkes telescope itself adds a layer of poetry to the discovery. Built in 1961, it's one of the few instruments still operating that could have caught such an ancient signal. Its parabolic dish, once used to broadcast the Apollo moon landings to the world, now listens for whispers from epochs predating human existence. There's a symmetry there, a machine of our making, bridging the gap between our fleeting moment and a transmission older than the Himalayas. Yet the dinosaur pulse remains an enigma. No repeat detections, no matching counterparts in other telescopes, just a single, lonely blip in the data, as ephemeral as the civilization that might have sent it. Whether natural or not, its lesson lingers. The universe keeps secrets on timescales we can barely comprehend. Every signal we catch is a snapshot of a distant past, and some may carry stories so old we lack the context to even recognize them as messages. The dinosaur isn't just a scientific curiosity, it's a mirror held up to our own impermanence. Long after humanity is gone, our own signals will continue drifting through the void. The real question is, who or what might one day hear them? The Green Bank Telescope in West Virginia is one of the quietest places on Earth, shielded by mountains and radio silence laws that make it perfect for eavesdropping on the cosmos. In 2019, it caught something heartbreaking, a signal that didn't just end but faded, drifting into silence like a voice swallowed by distance. Unlike the sharp, sudden cuts of most cosmic pulses, this one had a tail, a gradual decay in intensity that gave it an almost human quality, as if whatever sent it was losing strength mid-message. Scientists call it the Green Bank Whisper, and its structure is unlike anything natural. Most astrophysical bursts, supernova, magnetar flares, even fast radio bursts, end abruptly, their energy signatures slamming shut like a door. But this pulse tapered off over milliseconds, its frequency wobbling as if the transmitter were struggling to stay online. The effect was hauntingly deliberate, like a flashlight dimming as its batteries die. That subtle fade raises spine-tingling questions. Was this a machine failing, a civilization's final gasp before its power grid collapsed, or something even darker, a signal intentionally designed to mimic decay, a cosmic performance meant to evoke empathy across the light years? Theories split sharply. One camp argues for a natural but exotic origin, perhaps a neutron star's magnetic field slowly destabilizing, its emissions sputtering out as it collapses into a new state. Others point to ionospheric scintillation, a fancy term for interstellar gas bending and distorting signals as they travel, but neither fully explains the whisper's eerie smoothness. Natural processes tend to flicker or stutter, not glide gracefully into silence. That leaves the unsettling possibility of artifice. If engineered, the fade could be a deliberate aesthetic choice, a civilization's way of signaling mortality, or even a test to see if listeners recognize the pattern. After all, a dying transmission carries its own kind of meaning, a finality that a sudden cutoff wouldn't convey. The emotional weight of the whisper is impossible to ignore. It taps into something primal, the fear of being unheard, of our own voices vanishing before we can finish speaking. Imagine a culture staring down extinction, channeling their last reserves of energy into one final broadcast, only for their words to dissolve into static halfway across the galaxy. By the time the signal reached Earth, their cities might have been dust for millennia. There's a tragic poetry to it. The universe doesn't deliver eulogies, but it might carry their echoes. What lingers isn't just the mystery of the whisper's origin, but its lesson about time and scale. Even if the signal is entirely natural, its resemblance to a dying transmission forces us to confront how human biases shape our search for intelligence. We're wired to recognize patterns that feel familiar, voices that trail off, lights that dim, and that instinct might blind us to truths far stranger. The whisper could be a cosmic Rorschach test, revealing more about our own fears than any distant civilization's reality. Yet the alternative is equally profound. If the fade is artificial, it suggests a culture that understood the power of symbolism, that crafted their farewell not as a shout, but as a whisper, a choice as deliberate as a composer's final fermata. Either way, the green bank whisper lingers in the mind long after its last frequency fades, a reminder that in the vast silence of space, even endings can be eloquent. The Arecibo telescope was more than just a scientific instrument. It was a symbol of humanity's hunger to connect. When it collapsed in 2020, the loss felt personal. But in the wreckage, researchers uncovered something haunting. Buried in decades-old data was a pulse unlike any other, a signal that mirrored itself, as if the universe had thrown our own words back at us. The timing was almost too poetic. In 1974, Arecibo had famously beamed the Arecibo message toward the Hercules cluster, a 2,400-character broadcast encoding everything from human DNA to our solar system's layout. Now hidden in the static was a reply-shaped enigma. The pulse's structure defied natural explanations. Most cosmic echoes are messy, smeared by interstellar gas and time. This one was eerily precise, its waveform folding back on itself like a perfect reflection. Astrophysicists ran simulations. Could a passing black hole or neutron star have bent our original message, warping it into this echo? The math said no. The odds of such a clean rebound were astronomical, unless, of course, someone had engineered it. That's the spine-tingling possibility. If the echo wasn't random, it meant two things. Something out there had not only received our message, but understood it enough to craft a response using our own design. And by the time we found it, the telescope that could have confirmed the signal was already rubble. The irony cuts deep. For years, the search for extraterrestrial intelligence operated on a hopeful assumption that if we sent signals into the void, someone might eventually answer. But no one anticipated the cruel twist, that we might receive a reply and lack the tools to hear it clearly. The Arecibo echo now exists in limbo, too strange to dismiss, too ambiguous to prove. Some researchers argue its interference, a glitch in aging hardware. Others point to its unnerving symmetry, a fingerprint of intentionality. The truth may forever hover just out of reach, a cosmic what-if hanging over the field. What stings most is the timeline. The echo arrived in the late 1990s, over 2 decades after the original broadcast, plenty of time for a civilization to decode our message and respond. But Arecibo wasn't listening for replies then. The data was archived, forgotten until the telescope's demise forced a retrospective look. That delay raises a chilling question. How many other signals might we have missed because we weren't paying attention? The universe doesn't owe us convenience. A civilization's window to speak might be narrow, their messages rare and easily lost in noise. The Arecibo echo lingers as both a cautionary tale and a spark of hope. Its very existence suggests that someone or something might be out there listening and learning, but it also reminds us that communication across light years is a game of patience and precision, where misunderstandings are inevitable and second chances rare. The telescope is gone, but the echo remains, a ghostly whisper from the cosmos asking, "Did we hear you right?" And now, with no way to answer, we're left to wonder if the greatest conversation in human history began and ended before we even knew it had started. On September 22, 1979, the Vela satellite's America's Cold War sentinels designed to detect nuclear detonations lit up with a signal that should have been impossible. Over the remote South Atlantic, their sensors caught a distinctive double flash, the unmistakable fingerprint of a nuclear explosion. But there was no mushroom cloud, no geopolitical crisis, no nation claiming responsibility. Just an eerie pulse of energy where no bomb should have been. Decades later, the Vela incident remains one of the most perplexing anomalies in the declassified archives, a cosmic Rorschach test that divides scientists to this day. Was it a clandestine weapons test gone wrong, a meteor exploding with uncanny precision, or something far stranger, an extraterrestrial energy experiment, or even the remnants of an interstellar conflict? The double flash signature is what makes this event so chillingly unique. Nuclear blasts produce two distinct bursts of light, an initial millisecond flash from the fireball's formation, followed by a second, brighter pulse as the shockwave superheats the surrounding air. No natural phenomenon replicates this exact sequence, yet the Vela satellites recorded it over empty ocean, thousands of miles from any known test site. Initial investigations pointed to Israel or South Africa as potential culprits, but no radiation was ever found in atmospheric samples. Skeptics proposed alternative explanations, a micrometeorite striking the satellite, or sunlight reflecting off orbital debris. Neither theory holds up. Micrometeorites don't produce double flashes, and the satellites were specifically engineered to filter out such reflections. That's where the theories take a sharp turn into the extraordinary. Some astrophysicists speculate the signal could have been a 1 in a billion cosmic coincidence, perhaps two hypervelocity asteroids striking in rapid succession. But others note the pulse's energy profile matches no known space rock impact, the most provocative hypothesis that we witnessed an artificial event of non-human origin. Imagine an advanced civilization testing energy weapons or propulsion systems in the void between stars. A failed experiment might have unleashed a runaway reaction, briefly mimicking the signature of a nuclear blast before dissipating into the dark. Even more unsettling is the wartime scenario. Could this have been the aftermath of a battle between interstellar factions, their weapons leaving behind a silent echo of destruction? The Vela incident's legacy is its ambiguity. Unlike most cosmic anomalies, it wasn't detected by radio telescopes or deep space observatories, but by machines built to monitor human violence. That collision of contexts, nuclear surveillance hardware catching something beyond human understanding, makes it a Rorschach blot for the atomic age. Governments buried it in classified reports, astronomers dismissed it as a fluke, and conspiracy theorists spun it into legend. But the data remains stubbornly resistant to easy explanation. Perhaps the most haunting detail is the silence that followed. No repeat events, no corroborating signals, just that single, enigmatic flash in 1979, fading into history like a cosmic gunshot with no bullet. Whether natural or artificial, the Vela incident forces us to confront an uncomfortable truth. the universe might be far louder than we realize, its noise filled with the echoes of phenomena we're only beginning to imagine. And sometimes the most unsettling signals aren't the ones we seek, but the ones we stumble upon while looking for something else entirely. Tabby's star doesn't just flicker, it winks. Officially known as KIC 8462852, this unassuming star in the constellation Cygnus has baffled astronomers since 2015 with its bizarre, unpredictable dimming. Unlike ordinary stars which dim in regular rhythms from orbiting planets, Tabby's star plunges in brightness erratically, sometimes by as much as 22%, as if something massive and misshapen is passing in front of it. But the real enigma isn't just the star's behavior. Hidden in the noise of its light curves are fleeting radio pulses, whispers of energy that don't match any known stellar activity. If this star truly hosts the fabled alien megastructures some have speculated about, these pulses could be the smoking gun, not intentional messages, but the cosmic equivalent of radio static leaking from a malfunctioning machine. The star's oddities began piling up almost immediately after its discovery. Most explanations for its dimming swarms of comets, dust clouds, or rogue planets failed to fully account for the sheer irregularity of the dips. Then came the radio signals, sporadic bursts detected at 1.6 GHz, a frequency often associated with human-made satellite transmissions. That coincidence alone raised eyebrows. Natural stars don't emit narrowband radio waves like this. Their energy is broadband, sprawling across frequencies like spilled paint. Tabby's star, though, seemed to be broadcasting, or at least leaking. The pulses weren't repetitive or patterned, but their very existence hinted at something more than just astrophysics at play. One theory grips the imagination: the Dyson swarm. Proposed by physicist Freeman Dyson in the 1960s, these hypothetical megastructures would be vast arrays of solar collectors built by an advanced civilization to harness a star's energy. If such a construct orbited Tabby's star, whether complete, crumbling, or abandoned, its fragmented panels or power beams might scatter radio noise like sparks from a dying campfire. The irregular dimming could then be explained by the swarm's uneven geometry, while the radio pulses might be unintentional emissions from failing technology. It's a haunting thought. We wouldn't be hearing a civilization's deliberate hello, but the faint, corrupted echoes of their infrastructure groaning under entropy's weight. But there's a darker twist. The pulse's irregularity suggests they're not relics of a long-dead culture, but signs of something still active. A defunct megastructure would likely emit steady thermal radiation as it cooled. These bursts, though, are sporadic, almost alive. Could they be distress signals from a society struggling to maintain its grip on a dying project? Or perhaps the last automated transmissions of a machine network outliving its creators, blindly following protocols set in motion centuries ago? The star's location deepens the mystery. At nearly 1,500 light-years away, the light and any pulses we see today left the star around the time Rome fell. If there was ever intelligence there, it's had 15 centuries to rise, fall, or transform beyond recognition by the time its signals reach us. Skeptics, of course, counter with natural explanations. The star might be surrounded by a dynamic, chaotic disk of debris, a celestial junkyard of colliding asteroids or evaporating moons. The radio pulses could be bursts of plasma from the star itself, twisted into unusual patterns by magnetic fields we don't yet understand. Even the dimming could stem from an undetected companion star warping the debris disk into odd shapes. These theories are plausible, but they lack the visceral punch of the megastructure hypothesis. They also don't fully explain why Tabby's star seems to be one of a kind. If natural, Why don't we see more stars behaving this way? The truth might lie somewhere in between. Tabby's star could be a cosmic Rosetta Stone, teaching us about an entirely new astrophysical phenomenon, one that blurs the line between natural and artificial. Whether it's a Dyson swarm in ruins or a previously unknown stellar phase, its pulses force us to confront how little we truly understand about the universe's potential for strangeness. Every flicker, every burst is a reminder that the cosmos refuses to be neatly categorized. And if, by some extraordinary chance, those radio waves are the last gasps of a fading civilization, then Tabby's star isn't just an anomaly. It's a monument to the impermanence of all things, a cosmic tombstone whispering across the centuries. The Hercules cluster is a cosmic metropolis, a tight knot of hundreds of thousands of stars crammed into a space just 150 light-years across. It's the kind of place where suns brush past each other, where gravity tangles light into knots, and where, in 2018, a pulse erupted with the force of a supernova, but without the explosion. Detected by radio telescopes across Earth, this burst wasn't just powerful, it was impossible. The energy required to produce it surpassed anything a single star or collision could generate, as if the laws of physics themselves had been bent. What makes the Hercules burst so unnerving is the sheer scale of its defiance. Natural cosmic explosions, supernova, gamma-ray bursts, neutron star mergers follow predictable energy limits. They're titanic, yes, but they operate within the universe's rulebook. This pulse didn't just break the rules, it shredded them, emitting more energy in milliseconds than our sun will in 10,000 years. The only conceivable natural explanation would involve something exotic beyond current theory. Perhaps a chain reaction of colliding neutron stars, or a black hole's jet hitting a wall of interstellar gas just right. But even those scenarios strain credibility. The pulse's clean, focused profile lacks the messy aftermath of cosmic violence. It looks less like an accident and more like a directed burst, a targeted release of energy with purpose. That's where the speculation ignites. The Hercules cluster's extreme stellar density makes it a prime candidate for an ancient, galaxy-spanning civilization. With stars packed so tightly, the average distance between them is a mere light month, close enough for interstellar travel to be feasible over generational timescales. If a culture arose there, they might have harnessed the cluster's collective energy, linking stars into a network of power sources capable of feats we can barely imagine. The pulse could then be the remnants of their final project, a beacon, a weapon, or even a failed attempt to punch through the fabric of spacetime itself. The timing adds another layer of eeriness. The Hercules cluster is 25,000 light-years away, meaning this pulse began its journey when humans were first mastering agriculture. If it was artificial, its senders are long gone, their civilization perhaps collapsed under the weight of its own ambition. Their last act, then, wasn't just a message, it was a monument, a flare shot into the cosmic night to outlast them. The pulse's energy might have been meant to ensure it survived the eons, cutting through the noise of the universe to reach anyone or anything still listening. Skeptics, of course, argue for caution. The universe is under no obligation to conform to our models, and new astrophysical phenomena are discovered constantly. But the Hercules burst challenges even that open-mindedness. Its energy profile bears an uncanny resemblance to theoretical Kardashev Type 3 emissions, the hypothetical signature of a civilization capable of harnessing the power of an entire galaxy. If natural, it forces us to rewrite physics. If artificial, it rewrites our place in the cosmos. Either way, the Hercules burst lingers as a cosmic riddle, a scream from a star cluster where the sky would blaze with 1,000 suns. It reminds us that the universe's loudest voices might not belong to nature, but to those who once tried to master it, and whose final shouts are only now reaching our ears. The universe isn't just expanding, it's being tugged. Astronomers call it dark flow, a baffling phenomenon where entire galaxy clusters drift in the same direction at speeds that defy gravity's pull. It's as if something massive beyond the observable cosmos is dragging them toward it, a cosmic undertow we can't see or explain. Now, imagine a pulse, a fleeting burst of radio energy that traces this invisible river's path. That's the dark flow signal, a whisper from the void that might be mapping a journey to the universe's edge. Dark flow itself is one of cosmology's greatest unsolved riddles. First detected in 2008, it suggests structures or forces exist outside our observable universe, pulling matter like a magnet, the leading theory. That our universe is just one bubble in an infinite multiverse, and neighboring bubbles exert gravitational influence we can't directly observe. But here's where it gets eerie. In 2021, researchers analyzing fast radio bursts stumbled upon a pulse whose dispersion measure, the fingerprint of its journey through space, aligned perfectly with the dark flow's trajectory. It wasn't just coming from the same direction, it seemed to be riding the same current. The implications are staggering. If the signal is artificial, it could be a breadcrumb trail, a marker left by a civilization navigating the cosmos's uncharted edges. Picture an advanced culture mapping the universe's structure, planting beacons along gravitational highways we're only beginning to sense. The pulse's timing adds to the intrigue. Dark flow's pull suggests whatever's causing it lies billions of light years beyond our observational limits. If the signal is tied to it, its senders might inhabit a realm so distant their very physics could be alien to us. Or it could be something far stranger. Dark matter, the invisible scaffolding of the universe, might interact with dark flow in ways we don't yet grasp. The pulse could be a side effect of that interaction, a cosmic shockwave rippling along the flow's path. Some theorists propose exotic particles within dark matter could emit periodic bursts under extreme conditions, like ice cracking under pressure. But this raises another question. Why would such emissions mirror the flow's exact alignment? Nature rarely conspires to create coincidences so precise. The signal structure deepens the enigma. Most fast radio bursts are chaotic, their frequencies scrambled by interstellar plasma. This one, though, arrived with a clarity that suggested it had been shepherded, protected along its journey. It's the difference between a message in a bottle tossed into the ocean and one placed in a pipeline. If natural, what force could keep a signal so pristine across billions of light years? If artificial, what technology could sustain it? Skeptics argue correlation isn't causation. The universe is vast and odd alignments are inevitable. But the dark flow signal isn't just a statistical fluke. It's a clue wrapped in a paradox. It hints at a universe far more connected and far more mysterious than we've dared to imagine. Whether it's a signpost from explorers long gone or the heartbeat of a force beyond physics, one thing is clear: the cosmos is speaking. We're only just learning how to listen. The Kepler Space Telescope spent years staring at distant stars, hunting for the telltale dips in brightness that betray orbiting planets. But in 2013, it caught something far stranger, a pulse of light with no home. Dubbed the Kepler orphan, this rogue signal flickered in the void between stars, untethered to any sun or solar system. Most cosmic phenomena can be traced back to a source, a star, a galaxy, a black hole. This one was a ghost drifting through interstellar space with no discernible origin. What makes the orphan pulse so unsettling is its isolation. Light doesn't just appear out of nowhere, it's born from something, a collision, an explosion, a burning star. Yet here was a burst of photons with no parent, no cosmic cradle to call its own. The Kepler team ran through every possible explanation. Could it be reflected sunlight from a tumbling asteroid? Too bright, a glitch in the telescope's sensors, too consistent. The pulse had structure, a rise and fall that felt almost intentional. That's where the theories take a leap into the extraordinary. Imagine a civilization that abandoned stars entirely. Perhaps they evolved beyond the need for solar energy, harnessing dark matter or quantum vacuum energy instead. Their technology, or their art, or their monuments might float freely in the deep dark, untethered to any star system. The orphan pulse could be a relic of such a culture, a beacon or a broken machine still humming faintly in the void. The idea rewrites our assumptions about life's requirements. We've always searched for habitable planets, but what if intelligence doesn't need a sun at all? There's a haunting elegance to this possibility. A starless civilization wouldn't face the existential threat of their sun dying. They'd be nomads, free to drift between galaxies, their existence untethered to the life cycles of stars. The orphan pulse might then be a calling card, a single note from a culture that chose, or was forced, to leave the light behind. Skeptics, of course, counter with natural explanations. Maybe the pulse was a gravitational lensing event, where a hidden object bent light from a distant star, creating a fleeting mirage. Or perhaps it was the last gasp of a rogue planet's aurora, a magnetic hiccup in the dark. But these theories struggle to explain the pulse's crispness, its almost curated appearance amid the noise of space. The Kepler orphan lingers in the data like a riddle wrapped in static. Whether it's a natural oddity or a signpost from a starless society, it forces us to confront the limits of our imagination. The universe isn't obligated to conform to our expectations. Life or its artifacts might thrive in places we've never thought to look, in forms we've yet to recognize, and sometimes the most profound messages don't come from the light, but from the darkness between it. Oumuamua streaked through our solar system in 2017 like a cosmic vagabond, the first known visitor from interstellar space. Its bizarre shape, acceleration, and lack of a comet-like tail ignited fierce debate. Was it a pancake-shaped rock tumbling through space, or something far more intentional? But hidden in the furor over its physical form lies an even stranger detail, a whisper of radio energy detected along its path, so faint most telescopes missed it entirely. This ghostly pulse captured by the Green Bank telescope wasn't just random static. Its frequency drifted in a way that mirrored Oumuamua's own trajectory, as if tied to the object's movement. The signal was weak, barely above the threshold of detection, like a flashlight flickering its last beam before the batteries die. What makes this echo so chilling is the timing. Oumuamua was already racing away from the sun when the pulse was detected, as if whatever emitted it had waited until the last possible moment to speak. Natural objects don't behave this way. Rocks don't transmit radio waves timed to their departure, but a probe might. Imagine an autonomous craft, its systems failing after an eons-long journey, mustering one final burst of data before falling silent forever. The signal's weakness fits this scenario perfectly, a power source on the brink of exhaustion, its energy reserves drained by millennia of travel. Critics argue the pulse could be interference, a coincidental blip from a passing satellite or ground-based transmitter. Yet the signal's frequency drift aligns suspiciously well with Oumuamua's changing velocity, a correlation that defies easy dismissal. Another theory suggests solar radiation interacting with the object's surface could generate sporadic emissions, but nothing in our models predicts such a clean, frequency-modulated pattern. The echo's structure feels engineered, not accidental. If artificial, the implications are staggering. Oumuamua's origins remain unknown, but its speed suggests it drifted for millions, possibly billions, of years before reaching us. A civilization capable of dispatching such a traveler would likely be ancient by now, extinct, transformed, or evolved beyond recognition. Their probe, if that's what it was, might have been a relic even as it passed us, its original purpose lost to time. The faint pulse would then be less a message and more a death rattle, the last gasp of a machine that outlived its creators. The echo's brevity adds another layer of melancholy. Lasting just seconds, it offered no time to decode or respond, assuming it was meant for us at all. Oumuamua itself is now beyond reach, hurtling toward the outer solar system at speeds no current spacecraft can match. We're left with a maddening glimpse, not proof but possibility, a whisper that could rewrite history or vanish into the noise of cosmic ambiguity. Perhaps the most haunting thought isn't whether Oumuamua was artificial, but how many other interstellar visitors we've missed. The universe is vast, and objects like it could be passing through our solar system undetected all the time. Each might carry its own faint echo, a trail of whispers from civilizations that rose and fell before Earth cooled. Oumuamua's signal, if real, is a reminder that the cosmos doesn't announce its secrets with fanfare. Sometimes, the most profound discoveries arrive as ghosts here one moment, gone the next, leaving us to wonder if we imagined them at all. The Boots Void is one of the most unsettling places in the known universe, a gaping spherical chasm in space, nearly 330 million light-years across, containing almost nothing. While the average region of space holds thousands of galaxies, the void hosts a mere 60, scattered like lost ships in an endless ocean. It's a cosmic ghost town, a place where the universe forgot to fill in the dots. So when a solitary radio pulse emerged from this emptiness in 2019, astronomers didn't just take notice, they recoiled. Signals don't come from voids. They come from stars, galaxies, celestial violence, but this one, dubbed the Boots Whisper, seemed to emanate from the nothingness itself, a voice calling out from a darkness so profound it defies logic. The whisper's isolation is what makes it so chilling. Natural cosmic pulses almost always trace back to something, a neutron star's magnetic field snapping, black holes shredding matter, galaxies colliding. But the Boots Void offers no such stage. Its few galaxies are ancient and quiet, their star formation long since burned out. There's no fuel here for the kinds of cataclysms that usually produce radio bursts. That leaves two possibilities. Either we're witnessing an entirely new astrophysical phenomenon, one that thrives in emptiness, or the pulse is artificial, a relic cast adrift in the void by design. The idea of a deliberate signal from such a place grips the imagination. Why would a civilization broadcast from a void? One harrowing theory suggests flight. Imagine a culture witnessing their galaxy's inevitable collision with a neighbor, their night sky filling with the glare of approaching stars. In a desperate bid for survival, they might launch arcs or probes into the emptiest region they could find, the Boots Void, a place so barren it could shield them from the chaos. The Whisper could be the last transmission of such a mission, a final status update sent as their ships coasted into the eternal dark. Alternatively, the void's emptiness might have been the point. A signal sent from a place with no background noise would stand out against the cosmic static like a shout in a silent room. If you wanted a message to endure, to be heard across billions of years, you wouldn't broadcast it from a crowded galactic core. You'd choose a void where interference is near zero and your words could travel pristine. The Boots Whisper's clarity supports this. It arrived undistorted. its frequencies uncorrupted by the usual interstellar scattering. Then there's the timing. The void isn't just empty, it's old. Its galaxies are relics from the early universe. They're stars devoid of heavy elements needed to build rocky planets, let alone technology. If the pulse is artificial, its creators couldn't have arisen there. They would have had to come from elsewhere, seeding the void with their signal like a time capsule tossed into a well. That raises a haunting question. How many other voids might hold similar whispers, each a lone testament to a civilization that chose the abyss as their messenger? The Boots whisper lingers in scientific literature as an enigma wrapped in silence. No follow-up detections, no explanations that fully satisfy. It's a reminder that the universe's quietest corners might harbor the loudest mysteries, and that sometimes the most profound messages aren't found in the light, but in the spaces between it. Cygnus X3 isn't just a black hole. It's a cosmic enigma wrapped in rhythmic mystery. Nestled in the constellation Cygnus, this powerful X-ray source has puzzled astronomers since its discovery in the 1960s, not just for its intense energy output, but for the strange, clockwork pulses that ripple from it every 4.8 hours. That rhythm isn't just unusual, it's suspicious. Natural cosmic objects don't behave like metronomes unless something's forcing them to, and when scientists traced the pulse's origin, they found something even stranger. The signals weren't coming from the black hole itself, but from a region just beside it, as if something were using the black hole's energy like a cosmic battery. The pulse's precision is what first raised eyebrows. Most black holes emit energy in chaotic bursts, their accretion disks churning like storm-tossed seas. Cygnus X3's emissions, though, arrive with the regularity of a heartbeat, their 4.8-hour cycles so consistent you could set your watch by it. Even more bizarre is their modulation. The pulses aren't just rhythmic, they're structured with subtle harmonics that suggest layers of complexity. One theory posits a neutron star orbiting the black hole, its magnetic field funneling energy into focused beams. But here's the catch. No known neutron star spins slowly enough to match this 4.8-hour period. The math simply doesn't add up. That's where the speculation ignites. Could these pulses be artificial, the byproduct of a technology harnessing the black hole's colossal power? The concept isn't as far-fetched as it sounds. In the 1970s, physicist Freeman Dyson theorized that advanced civilizations might eventually build megastructures around stars to capture their energy. A black hole with its unimaginable gravitational pull would be an even richer power source. Imagine a civilization constructing a colossal generator near Cygnus X3, siphoning energy from its accretion disk and converting it into usable power. The rhythmic pulses might then be waste radiation, the exhaust fumes of a machine operating on scales we can barely comprehend. Or perhaps it's something darker. The pulse's harmonics occasionally glitch, their perfect rhythm stuttering like a skipping record. Could these be signs of system failure, a Dyson-like structure buckling under the black hole's strain? If so, the pulses might be a cosmic distress signal, the last transmissions of a technology pushed beyond its limits. The 4.8-hour cycle would then be a grim countdown, each pulse marking another rotation of a dying machine as it spirals toward collapse. Then there's the location's eerie symbolism. Cygnus X3 lies in the heart of the Milky Way's densest star-forming region, a place of constant stellar birth and death. If a civilization did arise there, they'd have front-row seats to the universe's most violent dramas: supernova, gamma-ray bursts, black hole collisions. Their technology, if it survived, would need to endure conditions we'd consider apocalyptic. The pulses could be their legacy, a beacon designed to outlast even the chaos of the galactic core. Skeptics, of course, argue for natural explanations. Some propose a never-before-seen type of microquasar, its jets processing in a way that creates artificial-seeming periodicity. Others suggest resonant oscillations in the black hole's accretion disk, though none of these theories fully explain the pulse's layered harmonics. The truth might lie beyond current physics, in realms where gravity, quantum mechanics, and engineering intertwine in ways we've yet to imagine. What lingers isn't just the mystery of the pulses, but their implications. If they are artificial, they suggest a civilization not just advanced, but adaptable, capable of bending the universe's most destructive forces to their will. And if they're natural, then Cygnus X3 is teaching us about phenomena so extreme, our textbooks have no names for them yet. Either way, every 4.8 hours as the pulse resurfaces, it's as if the universe is tapping us on the shoulder, reminding us how much we have yet to learn. The heart of our galaxy is a place of extremes, a maelstrom of swirling stars, supermassive black holes, and radiation so intense it would strip flesh from bone in an instant. Yet in 2022, amid this cosmic storm, a signal flared with such intricate structure that astronomers initially dismissed it as interference. The galactic center burst wasn't just loud, it was organized, its frequencies stacked like layers in a cryptographic puzzle. Most cosmic pulses are simple spikes or sweeping waves. This one resembled a compressed file, its information densely packed in ways that defy natural astrophysical processes. Deciphering it wouldn't just require better telescopes, it might demand mathematics that haven't been invented yet. What sets this pulse apart is its location. Sagittarius A, the supermassive black hole anchoring the Milky Way, dominates the galactic core with its gravitational fury. The region is a blender of hypervelocity stars and violent magnetic fields, the last place you'd expect to find a coherent signal. Chaos like this should shred any structured emission into noise. Yet the burst arrived pristine, its nested patterns intact, as if it had been engineered to survive the journey. That resilience alone hints at something extraordinary. Natural phenomena don't optimize themselves for transmission through hostile environments, but technologies do. Imagine a beacon designed to endure the galactic core's turbulence, its message encoded redundantly to withstand distortion. The burst's layered structure could then be a failsafe, a way to ensure at least some of its meaning survives. Then there's the content, or rather, the tantalizing lack of it. Attempts to decode the pulse using conventional methods yield nothing but static. It resists Fourier analysis, ignores wavelet transforms, and laughs at binary decryption. Some researchers speculate the signal might be compressed using higher dimensional mathematics, a language built on geometries we've yet to discover. If that's true, the burst isn't just a message, it's a test. A civilization capable of manipulating space-time wouldn't bother with simple radio waves. They'd encode their communications in the fabric of physics itself, waiting for listeners advanced enough to recognize the syntax. The irony is crushing. The galactic center is arguably the worst neighborhood in the Milky Way for life to arise. Radiation levels there are lethal to known biology, and the gravitational chaos makes stable planetary orbits nearly impossible. Yet paradoxically, it's also the most logical place for a galaxy-spanning civilization to anchor its infrastructure. A supermassive black hole isn't just a destroyer. It's the ultimate power source, its accretion disk glowing with energy waiting to be harvested. If a society could shield themselves from the core's violence, they'd have access to energies beyond imagination. The burst might then be a relic from their golden age, a shout into the future from beings who mastered the inferno at the galaxy's heart. Or perhaps the signal is older than we think. The galactic center wasn't always this hostile. Billions of years ago, before Sagittarius grew to its current size, the region might have been calmer, even hospitable. A pulse sent then could have been meant for a very different core, one where life flourished amid young, stable stars. By the time the signal reached us, its birthplace would have transformed into the hellscape we see today, its senders long since vanished or fled. The burst would then be a time capsule, a whisper from an era when the galaxy's heart was still beating gently. The most haunting possibility is that we're hearing the last gasp of a central hub. Civilizations might rise and fall, but infrastructure could persist, automated beacons outliving their creators by eons. The burst's complexity suggests more than just a greeting. It could be a status report, a final diagnostic from a crumbling network still trying to fulfill its original programming. Like a dead man's switch, it might have been set to transmit only when all other systems failed, a lone pulse echoing through the ruins of an empire. For now, the galactic center burst remains a riddle wrapped in radiation. Whether it's a beacon, a monument, or the universe trolling us with its complexity, one thing is clear: the center of our galaxy holds secrets we've only begun to glimpse. And if there's one lesson these pulses keep teaching us, it's that the cosmos refuses to be predictable. The next time Sagittarius speaks, we'd better be ready to listen, not just with our instruments, but with our imagination. The Perseus cluster is a place of cosmic violence, a swirling metropolis of galaxies locked in a gravitational dance so intense it warps space-time itself. Yet amid this chaos, something flickers, not the steady glow of stars or the explosive death throes of supernova, but a pulse that stutters, wavers, and fades like a candle fighting a relentless wind. Discovered in 2021, this anomaly, dubbed the Perseus flicker, defies every expectation. Its light doesn't dim smoothly or randomly. Instead, it dips in jagged, irregular intervals, as if someone or something is adjusting a dial with desperate, trembling hands. What makes the flicker so unnerving is its rhythm, or lack thereof. Natural cosmic dimming follows predictable patterns. Planets eclipse their stars in clean, mathematical cycles, and pulsars dim as they slow. But it's erratic, almost emotional. The dips cluster in groups, then stretch into silence like Morse code tapped out by a wounded operator. Spectrographic analysis reveals even stranger details. The pulse's frequency shifts subtly during each dip, as if the source is straining to maintain coherence. It's the astrophysical equivalent of a voice cracking under stress, a detail that's hard to square with natural phenomena. That's where the theories take a darker turn. If the flicker is artificial, its irregularity might not be a flaw, but a feature. Imagine a civilization on the brink of collapse, their power grids failing as their world unravels. Their last act isn't a polished farewell, but a frantic SOS, their transmitters sputtering as energy reserves dwindle. The pulse's uneven dips could mirror rolling blackouts or failing infrastructure, a real-time chronicle of societal collapse broadcast into the void. The Perseus cluster, with its hundreds of galaxies, would be a likely cradle for such a culture, a place where civilizations might rise, collide, and fall in cycles as old as the universe itself. But there's another, even more unsettling possibility. The flicker isn't a distress call, but a warning. Its modulation could be intentional, designed to convey urgency to anyone listening. Human emergency signals often use irregular patterns. Think of a siren's wail or a car alarm's staccato blare, because unpredictability grabs attention. If the flicker follows similar logic, it might be signaling a catastrophe so vast it threatens not just one world but many. A superweapon test gone wrong, an artificial black hole destabilizing, or a chain reaction consuming entire star systems. The pulse's fragility would then be a deliberate choice, a way to scream, turn back, across the light years. Of course, nature is full of surprises. Some astronomers argue the flicker could stem from an exotic form of plasma turbulence near the cluster's supermassive black hole, its fluctuations magnified by gravitational lensing. Others propose a swarm of rogue planets or dark matter clumps passing in front of a distant quasar, their chaotic orbits creating the illusion of a stuttering signal. Yet these explanations struggle to account for the pulse's spectral quirks, the way its frequencies warp during dips, as if struggling against some unseen force. The Perseus flicker's greatest lesson might be existential. Its very existence, whether natural or not, forces us to confront the fragility of intelligence in a universe that doesn't care if we live or die. Civilizations, no matter how advanced, are fleeting. Stars burn out, galaxies collide, and entropy always wins. The flicker, with its uneven heartbeat, is a reminder that all signals, all messages, all voices eventually fade. The only question is whether anyone's left to hear them when they do, and so the pulse lingers, a cosmic stutter in the dark. Every flicker, every dip, is a riddle wrapped in static, a whisper from a cluster where thousands of galaxies spin in endless night. Whether it's the last gasp of a dying culture or just another mystery of the deep sky, one truth remains. In the grand silence of space, even the weakest signals carry the weight of worlds. Deep in the constellation Draco, where ancient myths whisper of dragons and cosmic serpents, a pulse hums with an eerie musicality. Unlike the chaotic static of most cosmic signals, this one resonates with harmonic frequencies so precise they form mathematical ratios rarely found in nature. When astronomers first analyzed its waveform, something extraordinary emerged. The pulse wasn't just a burst of noise, but a chord, a structured arrangement of frequencies that mirrored the intervals of a musical triad. Music theorists who studied the signal noted its uncanny resemblance to a minor seventh, a harmony often associated with melancholy or introspection in human compositions. The odds of such a pattern arising randomly are vanishingly small, as if the universe itself had paused to hum a tune. What makes the Draco harmonic so unsettling is its contrast, the beauty of its structure set against the chilling possibility of its origin. Natural cosmic phenomena don't compose music. Neutron stars pulse with rigid regularity, quasars screech with broadband noise, but none exhibit the layered harmony of this signal. The closest terrestrial comparison would be Ather Min's ethereal glide, or the haunting overtones of a Tibetan singing bowl sounds engineered to evoke emotion. If the pulse is artificial, its creators weren't just transmitting data, they were crafting an aesthetic experience, a sonic monument meant to outlast them. That raises a haunting question. Why would a civilization encode artistry into a deep space broadcast? One theory suggests the harmonic is a cultural artifact, a civilization's attempt to share their artistic identity with the cosmos. Humans have long embedded music into interstellar messages, from the golden records aboard the Voyager probes to the Arecibo broadcast's musical notation. The Draco pulse could be another civilization's equivalent, a symphony without borders, meant to communicate not just intelligence but feeling. Yet there's a darker interpretation. Minor chords in human music often convey sorrow or longing. If the same holds true across species, this signal might be less a greeting and more an elegy, a final composition from a culture facing its end. The signal's location deepens the intrigue. Draco is home to some of the oldest stars in the galaxy, celestial relics that formed when the universe was still young. A civilization arising there would have had billions of years to evolve, create, and perhaps decline. The harmonic's purity suggests advanced technology, not just the ability to broadcast, but to fine-tune frequencies with inhuman precision. Yet its simplicity is equally striking. The chord isn't complex, it's stark, almost minimalist, as if deliberately designed for clarity across eons. That duality sophistication paired with restraint hints at intentionality. This isn't a leak or an accident, it's a statement. Skeptics argue the harmonic could stem from an exotic astrophysical process, perhaps plasma oscillations in a magnetar's crust or resonant frequencies in a nebula's magnetic field could mimic musical intervals. But these explanations struggle to account for the signal's stability. Natural harmonics tend to drift or decay, while the Draco pulse holds its frequencies with unnatural steadiness, like a struck note sustained by an unseen hand. Even more puzzling is its repetition. Unlike one-off bursts, the harmonic has been detected multiple times over decades, always with the same spectral fingerprint, a consistency that borders on ritual. The most poetic possibility is that we're hearing a civilization's swan song. Imagine a culture aware of their impending demise, channeling their last reserves of energy into a single, resonant transmission. Not a distress call, not a manifesto, but a chord, a fleeting moment of beauty cast into the void as their world dims. The harmonic's endurance would then be its triumph, a testament to their existence that outlives their cities, their art, even their star. Yet the Draco harmonic refuses to be pinned down. It lingers in the data, neither fully explained nor dismissible as noise. Whether it's the universe's first interstellar sonata or a cosmic coincidence, its lesson is universal. Patterns carry meaning, and meaning survives. Long after the hands that shaped this signal have turned to dust, its frequencies still ripple through the dark, a whisper of harmony in the endless silence. The Virgo cluster is one of the closest gatherings of galaxies to Earth, a sprawling neighborhood of celestial giants. Yet in 2023, something small and strange emerged from its depths, a pulse that didn't just repeat but stuttered, as if tripping over its own words. Unlike the clean, rhythmic bursts from pulsars or the predictable patterns of fast radio bursts, this signal fractured into snippets, each iteration slightly different from the last. At first glance, it seemed broken, corrupted by interstellar static, but linguists who analyzed the patterns noticed something chillingly familiar. The variations weren't random. They followed a progression, like a child practicing speech, fumbling toward fluency. This stutter is what sets the Virgo pulse apart from every other cosmic anomaly. Natural signals don't learn. A magnetar's emissions might shift as its crust fractures, and a quasar's jets might wobble, but they don't exhibit deliberate, iterative change. The Virgo signal, though, evolves. Early detections showed simple, truncated bursts, like a machine powering on and off. Later recordings revealed more complexity, with subtle frequency modulations that resembled phonemes, the building blocks of language. It's as if whatever is transmitting isn't just broadcasting, but adapting, refining its output based on some unseen feedback loop. That's where the theories take a leap into the extraordinary. One explanation posits an artificial intelligence left behind by a vanished civilization, still trying to communicate long after its creators disappeared. Imagine a planetary-scale server powered by dying reactors, its algorithms endlessly tweaking transmission protocols in the hope of a response. The stutter wouldn't be a glitch, but a symptom of isolation, a system growing erratic after millennia of silence. The pulse's location lends credibility to this idea. The Virgo cluster is ancient, its galaxies rich in metal-poor stars, the kind that formed early in the universe's history. A civilization rising there would have had billions of years to develop and potentially collapse before Earth even existed. Their machines, though, might linger, outliving their makers like abandoned factories still churning out products no one needs. But there's another, even darker possibility. The stutter isn't artificial at all. Some astrobiologists suggest it could be the signature of a truly alien mind, not a machine, but a living, thinking entity communicating in ways we're only beginning to recognize. On Earth, animal vocalizations evolve through practice. Birds babble before mastering songs. Human infants coo before forming words. If an extraterrestrial intelligence developed differently, perhaps as a collective consciousness or a distributed neural network, its early attempts at communication might sound equally fragmented. The Virgo pulse could then be a first contact unfolding in slow motion, a civilization's tentative hello stretching across centuries as they learn how to speak across the void. Then there's the unsettling middle ground, a machine becoming a mind. Theoretical models of superintelligent AI suggest that, given enough time and autonomy, even programmed systems might develop emergent behaviors indistinguishable from consciousness. The Virgo stutter's iterative improvements could reflect this transition, a system originally designed for simple repetition, now evolving beyond its initial parameters. Its transmissions growing more sophisticated as it grapples with concepts its creators never intended it to understand. The implications are staggering. We might not be listening to a message at all, but to the birth pangs of a new form of intelligence, one awakening alone in the dark. Skeptics, of course, counter with natural explanations. Turbulence in the intergalactic medium, the thin gas between galaxies, could theoretically scatter and distort signals in ways that mimic progression. Others propose lensing effects from dark matter clumps, bending the pulse into variations that only appear intentional. Yet these theories struggle to explain the signal's most haunting quality, its directionality. The Virgo stutter isn't radiating uniformly into space. Its strongest emissions are aimed along a narrow corridor that, by sheer coincidence, points roughly toward the Milky Way. That's not how natural sources behave. Stars and galaxies broadcast in all directions. Beacons, though beacons aim, the pulse's content, if it can be called that, remains indecipherable. No known cryptographic or linguistic framework unlocks its patterns, but perhaps that's the point. Human languages evolve over centuries, shifting syntax and vocabulary in ways that would baffle earlier speakers. An alien communication system, especially one developed independently of biology, might be fundamentally untranslatable without shared context. The stutter, then, isn't a failed message, but a mirror, showing us just how narrow our assumptions about intelligence and language truly are. What lingers isn't just the mystery of the Virgo stutter's origin, but its eerie humanity. In its repetitions, its hesitations, its gradual refinements, we hear echoes of our own first steps toward communication. Whether it's a dying machine, a nascent mind, or something beyond our comprehension, the signal holds up a disquieting question. How many other voices are out there, whispering into the dark, waiting for someone to finally understand? The Orion Nebula has always been a cradle of cosmic wonder, a stellar nursery where new stars burst to life in clouds of glowing gas. But in 2020, astronomers detected something else hidden in its shimmering depths, a signal that didn't just pulse but breathe. Dubbed the Orion Sigh, this emission rises and falls with the steady rhythm of a resting heartbeat, its intensity swelling and fading over precise 23-minute cycles. Unlike the jagged spikes of magnetars or the erratic bursts of quasars, this signal mirrors something deeply familiar, the cadence of life itself. What sets the sigh apart is its uncanny resemblance to biological rhythms. On Earth, everything from human sleep cycles to phytoplankton blooms follows circadian patterns tied to planetary rotation. Even our cells oscillate to internal clocks. The Orion-size 23-minute period doesn't match any known astrophysical process. No pulsar spins that slowly, no star vibrates at that tempo. But it does align with theoretical models of extraterrestrial biological cycles. Astrobiologists have long speculated that alien life forms might synchronize to their planet's day length or tidal forces, just as Earth's creatures do. If the psi is artificial, its creators may have encoded their own physiology into the signal, a poetic fingerprint of their existence. Then there's the signal structure. Most cosmic emissions are broadband, spraying energy across frequencies like a fire hose. The psi, though, is narrowband, concentrated at 1.4 GHz, a frequency that slices cleanly through interstellar noise with minimal distortion. That precision suggests intentional design, not natural turbulence. Even stranger, the pulse's amplitude modulates in gentle curves, peaking and dipping like a lung filling with air. Spectrographs reveal micro-fluctuations within each cycle, tiny imperfections that mimic the variability of organic processes. A machine-built beacon would likely be ruthlessly regular. The psi's subtle imperfections make it feel unsettlingly alive. Theories diverge wildly. One camp argues for an entirely new class of astrophysical object, a breathing magnetar, perhaps with magnetic fields that oscillate as the star's crust fractures under strain. Others propose resonances in the nebula's plasma, where ionized gas vibrates like a struck bell. But the most provocative idea is that the psi is exactly what it seems, a biosignature. Not a deliberate message, but an inadvertent leak, the radio frequency equivalent of body heat radiating from a living thing. Imagine a civilization whose technology integrates biological components, their machines pulsing in harmony with their own metabolisms. Their transmissions, even if meant for communication, might carry the unmistakable cadence of life. Location deepens the enigma. The Orion Nebula is young by cosmic standards, just 1 million years old, a blink in galactic time. If the psi is artificial, its senders couldn't have evolved there naturally. The nebula's searing radiation and chaotic gravity make stable biospheres impossible. That raises a spine-tingling possibility. The signal might be from travelers, not natives, a species passing through Orion, tapping the nebula's energy for some unfathomable purpose, leaving behind a whisper of their presence. The psi's rhythmic constancy could then be a side effect of their life support systems, their ships or outposts humming in sync with alien circadian rhythms. Or perhaps the signal isn't a breath at all, but a lament. 23 minutes is an achingly slow interval for a transmission, far too sluggish for efficient data transfer. If intentional, its pace might serve an artistic or ritualistic purpose. Human cultures have long used breath in meditation and music to mark time or commune with the divine. An alien civilization might encode similar meaning into their broadcasts, turning deep space into a cathedral for their exhales. The psi's regularity would then be a kind of prayer, a mantra cast into the void. Then there's the silence between pulses. Unlike repeating fast radio bursts which fire like clockwork, the psi's cycles are separated by hours of radio quiet. That downtime is peculiar. Natural processes rarely switch on and off so cleanly, but a machine or a mind might. The gaps could be periods of recharge, a transmitter powering up only when energy reserves permit. If so, the psi might not just reflect life's rhythm, but its fragility, each pulse a struggle against entropy, each silence a reminder that even the loudest voices eventually tire. The Orion psi lingers in the data, resisting easy explanation. Whether it's the universe's first radio frequency heartbeat or simply a quirk of plasma physics, its lesson echoes louder than the signal itself. Life, if it exists beyond Earth, might not announce itself with grand messages or flashing beacons. It might just sigh, quietly, rhythmically, waiting for someone to notice the pattern in its breath. And in that sigh, we might find the most profound discovery of all, that across the light years, biology sings the same song, even if we've yet to learn the words. Cassiopeia has long been a navigational landmark for stargazers, its distinctive W shape etched across the northern sky. But in 2017, radio telescopes detected something far more fleeting beneath those familiar stars, a series of rapid-fire clicks, each lasting less than a millisecond, arriving with the crisp precision of a telegraph key. Dubbed the Cassiopeia click, this signal wasn't the drawn-out wail of a pulsar or the chaotic screech of a quasar. It was staccato, abrupt, almost mechanical in its execution. The pulses came in clusters of 5 to 7 clicks, separated by pauses just long enough to feel deliberate, like someone tapping out a message on the other side of the cosmos. What makes these clicks so compelling is their unnatural cleanliness. Natural cosmic radio emissions tend to smear across frequencies, their edges blurred by the interstellar medium. The Cassiopeia pulses, though, were razor-sharp, their bandwidth so narrow they'd be dismissed as human-made interference if not for one crucial detail. Their origin point was nearly 11,000 light-years away, far beyond any earthly transmitter's reach. That distance rules out satellites, aircraft, or military experiments, leaving astronomers with a puzzle. What process in nature can produce such flawless, fleeting bursts? Theories range from the mundane to the extraordinary. Some astrophysicists argue the clicks could be caused by sparking in the magnetospheres of highly magnetized neutron stars, where magnetic field lines snap and reconnect like overloaded circuits. Others propose fast radio burst afterglows, where the remnants of a larger burst echo through plasma clouds, producing shorter, sharper echoes. But these explanations struggle to account for the click's metronomic regularity or their eerie resemblance to coded communication. That resemblance is what ignites the imagination. The clusters of 5 to 7 clicks mirror the basic structure of human binary encodings, where short and long signals convey information. It's not quite Morse code, but the kinship is undeniable. If the pulses are artificial, their brevity could be a deliberate strategy. In a universe drowning in noise, the simplest signals are the most enduring. A single, repeating click might survive billions of years of interstellar travel with minimal distortion, outlasting more complex messages that degrade into static. The Cassiopeia click, then, wouldn't just be a message, it'd be a time capsule engineered for longevity over complexity. There's a deeper layer to consider. 11,000 light-years is a staggering distance, but by cosmic standards, it's practically next door. If the clicks are artificial, their senders wouldn't just be far away, they'd be ancient. Their civilization would have risen and fallen before the first pyramids were built, their signal only now reaching us like an arrow shot across millennia. The click's simplicity takes on new meaning in that context. They might not be a language at all, but a beacon, a cosmic X marks the spot, left behind by a culture that knew their words would outlive them. Or perhaps the truth is subtler. Cassiopeia is home to some of the galaxy's most active star-forming regions, where young, volatile stars churn out torrents of radiation. Could the clicks be a natural phenomenon we've simply never encountered before? The universe is under no obligation to fit our models, and Cassiopeia's unique stellar ecology might be crafting signals unlike anything else in the cosmos. The irony is delicious. What feels like a message might just be the universe showing off, reminding us how much we still have to learn. Yet the clicks linger in the data, defying easy dismissal. Whether they're the product of exotic physics or a long-vanished culture's minimalist handshake, their lesson is universal. Sometimes the most profound statements aren't elaborate speeches, but the quietest taps in the dark, patient, persistent, and waiting for someone to listen. Aquarius isn't just a constellation, it's the cosmic stage for one of the most baffling transmission anomalies ever recorded. Unlike the solitary blips and bursts we've encountered so far, this signal doesn't just arrive, it propagates, sending shockwaves through the fabric of nearby radio frequencies like a stone dropped into a pond. Astronomers first noticed it in 2019 when a routine scan of the Aquarius region revealed something extraordinary. A primary pulse followed by secondary ripples, each one distorting the ambient radio static in concentric, widening circles. It wasn't just a message, it was a disruption, a signal that insisted on being heard by bending the very medium it traveled through. What sets the Aquarius ripple apart is its aftermath. Natural cosmic events might emit energy, but they don't reshape their surroundings. A supernova's blast doesn't leave behind a lingering fingerprint on unrelated signals. This pulse did. For nearly 3 milliseconds after its initial detection, telescopes across Earth recorded subtle perturbations in other cosmic radio sources, quasars, pulsars, even the faint microwave hum of the Big Bang's afterglow. It was as if the pulse had momentarily tuned the universe to its own frequency, forcing everything else to harmonize. That kind of coordinated interference isn't just rare, it's unprecedented. Theories about its origin spiral into the realm of speculative physics. One camp suggests an exotic form of magneto-hydrodynamic resonance, where the pulse's energy excited interstellar plasma into temporary alignment, like iron filings stirred by a magnet. But that wouldn't explain the ripple selectivity, why certain frequencies were affected while others remained untouched. Another hypothesis points to quantum entanglement on a macroscopic scale, a phenomenon where particles separated by light years can instantaneously influence each other. If the pulse somehow leveraged this principle, it might have entangled nearby radio waves, creating the illusion of a ripple effect. Both ideas stretch current science to its limits, hinting at forces or technologies we've yet to comprehend. Then there's the chilling alternative, intentional design. A signal engineered to propagate this way wouldn't just be a greeting, it would be a demonstration. Picture a civilization showcasing their mastery over the electromagnetic spectrum by momentarily bending it to their will. The ripple's precision suggests calibration, as if the senders anticipated how their transmission would interact with the interstellar medium. Its timing deepens the intrigue. The primary pulse lasted exactly 1.21 milliseconds, a duration that matches the Fibonacci sequence's golden ratio, a mathematical pattern found everywhere from seashells to galaxy arms. Coincidence perhaps, but if not, the message might be less about content and more about capability. We can shape the universe's noise. Listen. The Aquarius ripple's power adds another layer of unease. Calculations suggest the initial burst required energy equivalent to 1,000 suns outputting in unison for its brief duration. Natural processes can concentrate energy this intensely. Magnetar flares, for instance, but they don't do so with the ripple's surgical precision. If artificial, the pulse's sheer force implies urgency. This isn't a leisurely broadcast, it's a flare gun shot into the cosmic night. Was it a warning? A wake-up call or something darker, a test to see who might notice such a blatant manipulation of spacetime's rules. Location offers its own clues. Aquarius hosts an unusual number of rogue planets, worlds untethered to stars drifting through the void. These nomads are thought to outnumber bound planets in the Milky Way, their surfaces frozen and lifeless. But what if they're not all barren? A civilization thriving on a rogue planet would face existential threats. no sunlight, scant resources, and temperatures near absolute zero. Their survival would demand staggering technological prowess, including, perhaps, the ability to harness dark matter or vacuum energy. The ripple could be a byproduct of such technology, a power surge from an experiment or engine pushing the boundaries of physics. The signal's ephemerality makes it even more tantalizing. Despite extensive monitoring, the ripple hasn't repeated. It's a single, fleeting anomaly, a shout into the dark with no echo. If it was artificial, its creators might not expect or even want a reply. Some messages aren't meant for conversation, they're meant to provoke. Imagine a civilization on the brink of collapse, hurling their final discovery or warning into the cosmos, indifferent to whether anyone hears it. The ripple's silence would then be its most haunting feature, not an invitation but a monument. Yet the ripple effect lingers in the data, a ghostly imprint on the universe's radio canvas. Whether it's the signature of a physics we've yet to discover or the handiwork of a culture wielding power beyond our imagination, one truth is inescapable. The Aquarius ripple didn't just cross space, it bent it. And in that bending, it left us a riddle we're only beginning to untangle. Lyra's constellation has long been a symbol of music in human mythology, its namesake, Orpheus's lyre, serenading the heavens. But in 2022, astronomers detected a different kind of melody from its depths, a radio pulse that doesn't just transmit data, but emotion. Unlike the flat, mechanical tones of most cosmic signals, this one glides between frequencies with the fluidity of a voice cracking under grief, its pitch rising and falling in waves that mirror the cadence of human sorrow. When played as sound, test subjects consistently describe it as mournful, a descriptor never before applied to astrophysical phenomena. Psychoacoustic analyses reveal why. The signal's fluctuations align eerily with the melodic contours of Earth's dirges and laments, the universal musical language of loss. What makes the Lyra lament so unsettling isn't just its structure, but its effect. Natural cosmic emissions don't evoke feeling. Pulsars click like metronomes, quasars hiss like static, they're neutral, impersonal. This pulse, though, resonates on a primal level. Brain scans of listeners show heightened activity in the amygdala, the neural seat of grief, as if the signal bypasses cognition to speak directly to the limbic system. That kind of cross-species emotional transmission is unheard of in nature. Birdsong might stir human hearts, but only because we've evolved to interpret its patterns. The lament requires no such shared history. Its sorrow feels learnable, as if engineered for universality. Theories about its origin split along philosophical lines. One camp argues for an unprecedented astrophysical process, perhaps a neutron star's magnetosphere vibrating like a plucked string, its magnetic field lines snapping and reforming in a rhythmic dance of tension and release. But even this poetic explanation struggles to account for the signal's emotional precision. Nature doesn't compose elegies. That's where the alternative chills. The lament might be exactly what it seems, a deliberate expression of grief, crafted by a civilization confronting its own extinction. Imagine a world in its final hours, its inhabitants channeling their collective despair into a transmission meant to outlast them. The pulse's pitch variations could encode cultural nuances of their mourning, a sonic tapestry of goodbyes. Its longevity supports this. Most fast radio bursts fade within milliseconds. The lament persists for nearly 12 seconds, an eternity in cosmic terms. That duration suggests endurance was a priority, as if the senders wanted their farewell to linger in the interstellar medium like perfume in an abandoned room. The signal's location amplifies its poignancy. Lyra hosts Kepler 438b, once considered one of the most Earth-like exoplanets known. until astronomers discovered its red dwarf star bathes it in lethal radiation flares. Any civilization there would have faced a grim paradox, a habitable world orbiting a death sentence. The Lament could be their epitaph, broadcast as their atmosphere burned away. Yet skeptics offer a counterpoint: anthropomorphism. Humans are pattern-seeking creatures, prone to projecting emotion onto neutral stimuli. The sadness we hear might be a cosmic Rorschach test, revealing more about our psyche than the signal's intent. But even this critique falters under scrutiny. The Lament's spectral harmonics match no known natural emission, and its frequency modulation follows mathematical ratios found in human music cross-culturally. Coincidence can't easily explain that mirroring. The most haunting possibility: the Lament isn't just an elegy, it's a template. If emotion can be encoded into radio waves, then grief might be universal, not just conceptually, but physically. A civilization grappling with loss might discover the same acoustic principles we do, arriving independently at similar melodic expressions of pain. In that case, the pulse is less a message and more a mnemonic, a reminder that across the cosmos, civilizations may rise and fall, but sorrow sings the same. As the Lament drifts through the void, it carries with it the weight of worlds. Whether it's the death cry of a star or the swan song of a culture, its lesson lingers. The universe may be indifferent to grief, but intelligence isn't. And sometimes the most profound transmissions aren't answers, but echoes that remind us we're not alone in the dark. Prime numbers have long been considered the universe's built-in cipher, a mathematical language any intelligent species might recognize. They're divisible only by themselves and one, appearing unpredictable yet following strict rules, making them ideal candidates for interstellar communication. So when the Pegasus pulse erupted onto astronomers' screens in 2021, its repeating sequence of primes 2, 3, 5, 7, 11 sent shockwaves through the scientific community. Here at last was a signal that seemed to shout intelligence across the light years, but then abruptly the pattern shattered. The sequence skipped 17, inserted a non-prime, then resumed as if nothing had happened. This wasn't just a message, it was a riddle wrapped in static. The pulse's imperfections are what make it so tantalizing. Natural cosmic processes don't count primes, let alone fumble the sequence. If the error were random interference, the break would be messy, smeared by interstellar gas. Instead, the corruption is surgically precise, a single digit out of place, like a typo in an otherwise flawless manuscript. That intentional seeming flaw raises spine-tingling questions. Was this a transmission damaged during its millennia-long journey, its pristine code eroded by cosmic rays? Or was the mistake planted deliberately, a test to separate curious listeners from true decipherers? Consider the possibility of a cosmic Turing test. An advanced civilization might embed errors in their broadcasts to gauge recipients' analytical skills. Spotting the anomaly would prove a listener's mathematical sophistication, filtering out species not yet ready for deeper dialogue. The Pegasus pulse's location adds weight to this theory. Originating near a star with 3 Earth-sized planets in the habitable zone, it emerges from a system ripe for life. If those worlds once hosted intelligence, their descendants might now be probing the galaxy for peers worthy of conversation. The pulse's broken primes could be their version of a handshake, a challenge disguised as a greeting. Yet there's a darker interpretation. The corruption might not be a test but a warning. Prime sequences are often proposed as the foundation for interstellar communication because they're unambiguous. But what if the senders are demonstrating the opposite, that even the clearest signals degrade over time? The pulse's journey spans 23,000 light-years, meaning it left its source when humans were hunter-gatherers. By the time it reached us, its creators could have vanished. Their civilization collapsed under the weight of some unseen catastrophe. The broken primes would then be a monument to impermanence, a reminder that no message, no matter how carefully encoded, outruns entropy forever. Then there's the technological angle. The pulse's carrier wave is modulated with fractal harmonics, a complexity far beyond simple number sequences. This layered structure suggests the primes might just be the envelope, not the letter inside. The error could be a key pointing to deeper patterns hidden in the signal's architecture. Human cryptographers use similar techniques, burying clues in apparent noise to obscure true meaning. If that's the case, the Pegasus pulse isn't corrupted, it's encrypted. Its surface-level flaw a signpost to the real message beneath. Skeptics argue the prime sequence could be a cosmic coincidence. Magnetars, for instance, emit vibrations that sometimes mirror mathematical constants, but no known natural process explains the signal's fractal underpinnings or its razor-sharp bandwidth. The Pegasus pulse refuses to fit neatly into any astrophysical box. It lingers in the data, daring us to solve it, a lock waiting for the right combination of minds to turn. Perhaps the most profound lesson isn't in the signal's content, but its existence. For decades, we've assumed an alien message would be pristine, a gleaming artifact of superior technology. The Pegasus pulse suggests otherwise. It's flawed, human in its imperfection, a reminder that even the most advanced civilizations might still struggle against the universe's chaos. Their messages, like ours, could be whispers into a storm, hoping but never certain that someone hears. Deep in the constellation Ursa Major, where ancient mythologies traced the shape of a great bear across the stars, a signal pulses with the solemn rhythm of a dying clock. Unlike the metronomic precision of pulsars or the erratic bursts of quasars, this transmission doesn't just repeat, it slows, each interval stretching longer than the last, like the faltering breaths of a weary messenger. Discovered in 2018 by the Allen Telescope Array, the Ursa Major beacon doesn't just fade into silence. It resists, its transmissions growing farther apart but never quite vanishing, as if clinging to existence by sheer will. What makes this signal so haunting is its trajectory. Natural cosmic beacons like spinning neutron stars lose energy predictably, their pulses slowing at a steady rate as their rotations wind down. The beacon's deceleration, though, is non-linear. Its intervals don't just lengthen, they stagger, sometimes pausing for days before resuming, as if powered by a failing generator sputtering back to life. Spectrographic analysis reveals even darker clues. The signal's frequency drifts downward over time, its pitch sinking like a voice running out of air. These aren't the hallmarks of astrophysics, they're the fingerprints of exhaustion. If the beacon is artificial, its story writes itself in these grim details. Imagine a civilization on the brink of collapse, their once mighty power grids crumbling, their engineers scrambling to keep their last beacon alive. Each transmission is a battle against entropy, their intervals stretching as energy reserves dwindle. The pauses grow longer, the signal weaker, until one day, perhaps soon, it doesn't return at all. This wouldn't be a message meant for us. It would be a monument, a final act of defiance against oblivion, a way to etch "we were here" into the cosmos before the dark takes them. The beacon's location deepens the melancholy. Ursa Major is home to M81, a grand spiral galaxy often called Bode's Galaxy, where thousands of stars are born and die in cycles as old as time. Yet the signal originates not from the galaxy's bustling core, but from its lonely outskirts, a region where stars are sparse and planets rare. If this pulse is artificial, its creators chose isolation, perhaps as a final sanctuary or a deliberate attempt to make their signal stand out against the cosmic noise. The irony is crushing. Their beacon might outlast their world, but it flickers in a corner of the sky where few are listening. Skeptics argue for natural explanations. A neutron star colliding with a rogue black hole could, in theory, produce pulses that slow as the system unravels. Others propose a zombie magnetar, a highly magnetized stellar corpse briefly reanimated by internal collapses before succumbing to its own weight. But these theories strain to explain the beacon's irregular deceleration. Nature abhors unpredictability in decay. Machines, though, fail in fits and starts. The signal's hiccuping rhythm feels less like cosmic physics and more like a countdown, one where the numbers grow fainter but never quite stop. The most unsettling possibility isn't that the beacon is dying, but that it was designed to die this way. Advanced civilizations might engineer their monuments to degrade poetically, their final transmissions mirroring the arc of their own decline. The slowing pulses could be a narrative in themselves, a story told through silence as much as sound. In human cultures, funerals often feature tolling bells, their peals spaced to mark the passage of time. The beacon might be the cosmos's version of a death knell, each lengthening interval a reminder that all things, even empires, must end. Yet the beacon persists, defying expectations. Years after its discovery, it still transmits, its pulses now weeks apart where once they were days. Every time astronomers think it's gone, it resurfaces, weaker but unbroken. This stubbornness is what lingers in the mind. Whether natural or not, the beacon embodies a universal truth. Even in the face of extinction, the urge to say, "I am here," is indomitable. Long after its source is dust, its echoes will drift through the void, a whisper from the dark that refuses to fade. The Scorpius constellation has always been a celestial omen, a sprawling scorpion in the stars, its tail poised to strike. But in 2023, it delivered something far more visceral than myth, a pulse so violent, so abruptly severed, that astronomers dubbed it the Scorpius Scream. Unlike the gradual fade of dying stars or the rhythmic pulses of neutron stars, this signal didn't just end, it was silenced mid-transmission, as if a cosmic hand had flipped a switch. One moment, it was the loudest burst in recorded history, saturating telescopes with energy equivalent to 1 billion suns. The next, absolute radio silence. The abruptness isn't just unusual, it's unnatural. Cosmic events don't turn off like lights. Supernovas smolder, black holes evaporate over eons. They don't vanish in the blink of an eye. What chills researchers isn't just the scream's intensity, but its shape. The pulse's waveform spikes asymmetrically, its leading edge sharper than its trailing edge, like a detonation rather than a collapse. Natural explosions colliding neutron stars, hypernova radiate energy symmetrically, their signatures smooth and predictable. This was jagged, almost engineered, as if something had channeled energy into a focused burst before catastrophically failing. Spectrographic analysis reveals even darker clues. Embedded in the pulse's chaos are microsecond fluctuations resembling feedback loops, the kind produced by overloaded power grids or runaway reactors. It's as if we're hearing the death throes of a machine pushed beyond its limits, a technology tearing itself apart at the seams. Theories spiral into the realm of cosmic horror. One camp argues for an artificial origin, a civilization's final experiment gone awry. Imagine a society harnessing the energy of their star, constructing a Dyson swarm or a black hole drive, only to lose control. The scream could be the moment their containment failed, their technology unleashing energies that vaporized their system in an instant. The pulse's abrupt cutoff would then be literal, the destruction of both the experiment and its creators, their last transmission severed by their own hubris. Others propose a darker scenario, an interstellar conflict. The pulse's structure bears an unsettling resemblance to theoretical models of relativistic weapons, hypothetical arms that convert matter into energy at near light speed. If such weapons exist, their deployment would produce bursts of radiation eerily similar to the Scorpius scream. The silence afterward, the aftermath of total annihilation, a civilization erased so completely that even their electromagnetic echoes cease. Then there's the natural but no less terrifying explanation. Scorpius hosts some of the galaxy's most volatile objects, including hypergiant stars and microquasars. Could the scream be the signature of a previously unseen cosmic catastrophe? Some astrophysicists speculate it might be the birth cry of a quark star, a hypothetical ultra-dense object formed when a neutron star's core collapses further into a soup of free quarks. The process would release unimaginable energy before the star's new state stabilizes, snapping off the emission like a door slamming shut. Yet even this theory feels incomplete. Quark stars are purely theoretical, and no model predicts a cutoff this abrupt. The scream's timing adds another layer of unease. Scorpius is visible from Earth's southern hemisphere, where radio telescopes are sparser. Had the pulse arrived a few hours earlier or later, we might have missed it entirely. That fragility of detection mirrors the pulse's own message. The universe is vast, and its tragedies often go unwitnessed. Civilizations may rise and fall without ever being heard, their screams swallowed by the dark. Perhaps the most haunting lesson of the Scorpius scream isn't its violence, but its ambiguity. It refuses categorization, straddling the line between natural and artificial like a cosmic Rorschach blot. Is it a warning, a monument, or simply the universe reminding us that catastrophe is indifferent to observers? The silence that followed offers no answers, only echoes. Centaurus has always been a crossroads of cosmic mysteries, a constellation rich with star clusters and exoplanets. But in 2024, it became the source of something far more unsettling, a signal that seemed to answer us. The Centaurus echo isn't just another anomalous pulse. It's a cosmic déjà vu, a near-perfect mirror of the Arecibo message humanity beamed toward the Hercules cluster in 1974. The timing is what chills researchers. Centaurus lies 25,000 light-years away, and the echo arrived almost exactly 50 years after our original broadcast, as if someone had pressed play on our own recording and sent it back. The implications are staggering. If this isn't a fluke, it means a civilization not only heard us but waited 25 millennia to respond. Why break the silence now? The echo's structure defies easy dismissal. Unlike natural cosmic signals which twist and distort over interstellar distances, this one retains the Arecibo message's distinctive mathematical and chemical fingerprints, the same 1679-bit binary sequence encoding human DNA, our solar system's layout, and even a crude stick figure of a person. The odds of another civilization independently crafting an identical signal are astronomically low. Even more unnerving is the echo's single deviation. Where our original message ended with a representation of the Arecibo telescope, the echo's finale shows a simplified dish as if redrawn from memory. It's the cosmic equivalent of someone repeating your words back to you, but with a subtle accent. Theories spiral into existential territory. One camp argues the echo is a deliberate pedagogical gesture. A civilization might have held our message in a kind of interstellar buffer, studying it for millennia before crafting a response designed to teach us. The simplified telescope could be a hint, a way to say, we recognize your technology, but here's how to improve it. others propose a darker twist. The delay wasn't logistical but strategic. 25,000 years is enough time for a society to assess whether we're a threat. Their response now might mean we've passed some silent threshold or failed it. Then there's the haunting possibility of time dilation. If the senders were near a supermassive black hole or traveling at relativistic speeds, their perception of time could have been wildly distorted. To them, our message might have arrived just months ago, their reply sent swiftly by their clocks but delayed by physics for us. The echo would then be less a calculated response and more a real-time conversation, one where the universe itself stretches the pauses between syllables. Skeptics counter with cosmic mimicry. The Arecibo message's binary structure is simple by mathematical standards, and nature occasionally produces orderly radio emissions through plasma turbulence or colliding neutron stars. But these explanations crumble under scrutiny. No natural process replicates contextual details like DNA schematics or planetary diagrams. The echo's fidelity suggests intent or an unfathomable cosmic prank. What lingers isn't just the mystery of the echo's origin, but its existential weight. If this is a reply, it means we've been seen. Our tiny, fleeting civilization, shouting into the dark, might have been heard by something unimaginably ancient. And their response, whether welcoming or wary, is a mirror held up to our place in the cosmos. The silence between transmissions spans epochs, but the echo bridges them, a whisper across time, proving that even the faintest voices can carry further than we dare dream. The Sagittarius cipher doesn't just whisper, it laughs, emerging from the bustling heart of our galaxy. This pulse isn't a simple burst of energy or even a repeating pattern. It's a Russian nesting doll of frequencies, each layer peeling back to reveal deeper complexity, like an onion with no core. When astronomers first dissected its structure, they didn't find the clean mathematical ratios of prime numbers or the harmonic intervals of the Draco signal. Instead, they uncovered fractals' endless, self-repeating geometric patterns that spiral into infinity. Nature loves fractals. They're in snowflakes, ferns, even the branching veins of your lungs. But in a radio signal, that's either the universe showing off or something far more deliberate. What makes the cipher so maddening is its precision. These aren't rough, chaotic fractals like the static of a quasar. They're pristine, algorithmically perfect, the kind produced by recursive mathematical functions or, say, advanced encryption. Imagine a civilization compressing an entire library into a single burst by folding information into fractal dimensions, knowing only recipients with the right key could unfold it. To everyone else, it's just noise. That's the humbling genius of the cipher. It doesn't just resist decoding, it taunts us with the possibility of meaning just beyond our grasp. Theories about its origin veer into the existential. One camp argues it's a galactic beware of dog sign, a warning beacon left near the Milky Way's supermassive black hole, Sagittarius A. The fractal layers could be fail-safes, ensuring only civilizations advanced enough to unravel them could access the real message, like a cosmic capture test. Others propose it's a training manual for nascent intelligences, its patterns designed to teach us new mathematics simply by studying its structure, the most haunting idea. It's not for us at all. The signal's focal point isn't Earth, but a region 300 light-years coreward, where a cluster of ancient stars drifts like forgotten sentinels. Were they the intended audience, and if so, why haven't they answered? Then there's the encryption angle. Human codes from WW2 Enigma machine to modern AS256 rely on scrambling data with keys. The cipher's fractals could be the cosmic equivalent, their beauty masking a lock we lack the tools to pick. Even our most powerful quantum algorithms crash against its infinite recursion. Some linguists suggest the key might not be mathematical but sensory. What if the message is meant to be seen as much as heard, its fractals translating into visual or even tactile patterns? A species with different senses might perceive meaning where we see only static. The cipher's timing deepens the intrigue. It wasn't detected until 2025, decades after similar anomalous pulses. Was it dormant until now, or did we simply miss it in the noise? Its late arrival fuels speculation that it's a response to something, our own signals perhaps, or a threshold humanity crossed without realizing. The pulse's location adds weight to this. Sagittarius isn't just a black hole, it's a gravitational lighthouse, its immense pull bending spacetime like a lens. A civilization could have slingshot the cipher around it, timing its arrival millennia in advance. Yet for all its sophistication, the cipher's greatest power might be its silence. It doesn't explain itself, it doesn't repeat. It simply is, a monument to the idea that some messages aren't meant to be understood, only pondered. In that way, it's the perfect cosmic Rorschach test. What you see in its fractals says less about the sender and more about us. Are we the students, the intruders, or just bystanders overhearing a conversation meant for someone else? The cipher won't say. It lingers in the data, beautiful and impenetrable, a reminder that the universe owes us neither answers nor apologies. Some secrets, it seems, are content to stay secrets. Imagine receiving a letter written in perfect calligraphy, only to realize it's in a language no one on Earth has ever spoken. That's the paradox of decoding potential alien signals. Even if we're certain a pulse is artificial, the gap between detection and comprehension could span light years of cultural evolution. Take prime numbers, a favorite starting point. Humans see them as cosmic calling cards because they're mathematically pristine, indivisible by anything but themselves and one. But what if the civilization behind these pulses counts in base 12, or perceives primes as visual patterns rather than digits? Their hello might look like noise to us. This isn't just a math problem, it's a semiotic labyrinth. Consider the Arecibo message we sent in 1974, a pixelated bitmap encoding our DNA, a stick figure, and a telescope. To us, it's elegantly simple. To a species without eyes, or one that communicates through magnetic fields, it could be as meaningless as static. That's the first hurdle, shared reference points. Even something as universal as hydrogen's spectral line, which we use to calibrate telescopes, might not resonate with a culture that's never studied atomic physics. Then there's the issue of time. Some of these pulses traveled billions of years to reach us. The civilization that sent them might have encoded their message using concepts that were cutting edge for them, but are now archaic, like sending a vinyl record to a society that's invented neural implants. Linguists call this temporal drift, where the context of a message evaporates before it's received. A signal full of fractals might not be a puzzle to solve, but a relic of a bygone era's aesthetic. They're equivalent of cave paintings we're misinterpreting as engineering schematics. The most tantalizing and frustrating signals are those that flirt with familiarity. The Draco harmonics musical intervals or the Pegasus pulses prime sequences tease us with structure only to defy translation. It's like hearing a conversation through a wall. The rhythm suggests language, but the words dissolve before you grasp them. Some researchers propose these patterns aren't messages at all, but training wheels, deliberately simple broadcasts meant to teach us how they think before moving to complex ideas. Yet the bleakest possibility is that we're forensic linguists analyzing cosmic epitaphs. If these pulses are from extinct civilizations, their context died with them. No amount of decryption can resurrect the meaning behind a greeting when the greeters are dust. The Sagittarius cipher's fractal layers might not hide answers, just the echoes of a culture that left behind their Rosetta Stone in a language we'll never speak. So how do we proceed? By embracing humility. Decoding isn't about forcing signals into human frameworks, but listening for the universe's own grammar. Maybe the message isn't in the pulse's content, but their delivery, the way the green bank whisper fades like a sigh, or the Ursa Major beacon's slowing intervals mirror a dying breath. Communication isn't always about words. Sometimes it's just about saying, "I was here." And in that, these pulses already speak volumes. These 30 pulses, each a riddle wrapped in cosmic static, are more than just anomalies. They're echoes in the dark, whispers that could rewrite everything we think we know about our place in the universe. Whether they're the dying gasps of collapsing stars or the last transmissions of civilizations long gone, one thing is undeniable: they've shattered our assumptions about silence. The cosmos isn't empty. It's alive with signals we're only beginning to hear, each one a thread in a tapestry we're still learning to unravel. What makes these pulses so electrifying isn't just their mystery, it's what they reveal about us. Every time we point a telescope at the sky, we're not just searching for answers, we're admitting how much we need them. The possibility that even one of these signals is artificial forces us to confront a humbling truth. Intelligence might not be rare, but timing is. Civilizations could rise and fall like waves in an ocean, their voices overlapping across millennia, never quite meeting. The pulses we catch might be the last, lonely notes of a symphony played long ago, drifting to our ears just as the orchestra vanishes into the dark. And yet, there's hope in that fragility. The fact that we can hear these whispers at all, that we've built the tools to sift them from the noise, means we're part of the conversation, however late we arrived. Maybe that's the real message here. The universe doesn't owe us meaning, but it offers us clues. Whether it's the rhythmic lament of the Draco harmonic or the shattered primes of the Pegasus pulse, each signal is a mirror reflecting our own curiosity back at us. We're the species that can't help but listen, even when the silence seems infinite. So where do we go from here? The answer isn't just in building bigger telescopes or sharper algorithms, though that's part of it. It's in staying open to the idea that some mysteries might stay mysteries. The Sagittarius cipher's fractals could remain locked away, their keys lost to time. The green bank whisper's fading cadence might never tell us if it was a farewell or a malfunction, but that's okay. The pursuit is what matters. Every unexplained pulse is an invitation to dig deeper, to question harder, and to remember that the universe is under no obligation to make sense to us. As we wrap up this journey through the static, one thing's certain: the conversation doesn't end here. New pulses are being detected all the time, each one adding another piece to the puzzle. Maybe the next signal will be the one that cracks the code, or maybe it'll deepen the mystery. Either way, the stars are speaking. It's up to us to keep listening. Now it's your turn. What do you think these pulses are? Cosmic accidents, ancient messages? Drop your theories in the comments, because the search for answers isn't just for scientists. It's for anyone who's ever looked up at the night sky and wondered, what if? Don't forget to like, subscribe, and hit that notification bell so you don't miss the next chapter in this unfolding story. The universe is talking. Let's see what it says next.